Hi, welcome to this video about normal distribution, a bell-shaped curve. That's another name for it. I'll explain what a normal distribution basically entails. First, we start off with thinking about binomial distribution because that's what we've done so far. If we flip a coin 10 times, we can make a binomial distribution to see what the probabilities are to get a certain outcome. This means that we can make a histogram stating what the probabilities are to get an outcome of, for example, 3 heads. Alright, let's see that graph. Alright, this is it. For 10 times, flipping a coin 10 times, this is what we get. We get a symmetrical graph with the center at 5. Alright, which makes sense because if we flip a coin 10 times, it's pretty usual to think that we can we get 5 heads, right? 50, which is a 25% chance, or a probability of 0.25. All right. If we would do this 20 times, 20 tosses of a coin, this is the graph that we will get. Again, symmetrical, and a center at 10. All right. Now, if we do it 50 times, this is what we'll get. All right. 50 tosses gives us a symmetrical graph with a center at 25, which again makes sense because it's halfway. Now, if we do it 100 times, this is the graph that we'll get. And you see that everything beyond 35 and 65 is not listed here because those values are really unlikely to get. All right, they're not impossible, but they're unlikely, so they're not shown in this graph. All right, and again, center around 50. All right, the more trials we do, we can make a more precise histogram. And this is what we call a normal distribution. Not yet, but this is what it sort of looks like. Center is called mean, and we write it like X bar. Right, X with a line above it, saying average, mean, or X bar. And in this case, that was 50. A normal distribution always has a mean, and that's the center of the graph, and it always is symmetrical. If we make a line graph, because that's what our normal probability will be, we get this graph. See that graph? Almost exactly one of the tosses, and it is a nice curve. All right, again, symmetrical, and it has a mean in the middle. This is another type of probability distribution. We also looked at, for example, binomial distribution. That's what the one we had here with the numbers of head. It was a histogram. Now we're looking at normal distribution, and a normal distribution is a really nice curve. And as you can see, it kind of looks like a bell. That's why we also call it the bell-shaped curve, because any normal distribution has this shape. Some of them are a little bit wider, some of them a little bit smaller, some higher, some lower, but they all look like a bell. All right, a normal distribution has a mean and a standard deviation. And the standard deviation, I'll try and explain this easily, what it actually means. The mean is always in the middle, right? The center, average, all names for it. And you see here on the bottom, you see that it's X bar. Then, all right, standard deviation is called, is notated as sigma. And it actually says something about spread. This sigma sign is from the Greek alphabet, right? It's a small sigma. Capital sigma is different. A normal curve shows all the probabilities. That means that in total it represents a probability of 1, because that means that you're sure that something is happening. All right, because that's always the case. Even if you have a coin toss, you toss a coin for 100 times and you get 0 heads, or you're trying to figure out the probability of getting 0 heads, that still means something happens, even though you get 0 times what you actually wanted. All right, something happens. Probability of 1 means always something. All right, and we said the area underneath the curve is 1. That's what we say it means to have this bell-shaped curve. The following properties are also for a normal distribution. The total area underneath the curve is 1, as I said. About 68% of the area lies within 1 standard deviation of the mean. 95% of the area lies within 2 standard deviations of the mean. And about 99.7% of the area lies within 3 standard deviations of the mean. Alright, this does not really explain what standard deviation is. As I said, standard deviation says a lot about spread. And spread means how far apart are the values, or how are the values different from each other? How far are they apart? Well, it doesn't actually say how far they are apart, because for every type of data it could be different. But it does give us this list of properties. Alright, in the example here, the standard deviation was 5 and the mean was 50. X bar is 50, sigma is 5. Alright, I'll try to show you what that means for our standard deviation. 68% of the area lies within 1 standard deviation away from the mean. This tells us that 68% of the probabilities lie between 5 above 50 and 5 below 50. And if you think about it, that means that there's a 68% chance of getting a value between 45 and 55. Meaning, if I toss a coin 100 times, the probability of getting between 45 and 55 is 0.68. Return it back into probability, because probability always is notated as a value between 0 and 1. Alright, if you look at the graph, you see that 68% is in between x bar minus sigma and x bar plus sigma. Alright, that's what it means in those cases. Alright, then 95% of the area lies within 2 standard deviations away from the mean. What this tells us is that 95% of all the probabilities lie between 2 times 5 above the mean and 2 times 5 below the mean. Or, in other words, 40 and 60. So the probability of getting 40 to 60 head in a 100-time coin toss is 0.95. Then the third one that we have is 99.7, which is in between 3 times the standard deviation plus the mean, and the mean minus 3 times standard deviation. All right, so that's the 99.7. We also call this the 68, 95, 99.7 rule, because those are the 3 most important, most common values of percentages. Good to remember. All right, if the standard deviation is different, slim, all right, very small, like the middle graph here, the graph will be slimmer. If the standard deviation is a greater value, you see that on the left and on the right, the normal model would be a little bit wider. But for all of these, they have a bell-shaped curve, and 68% of the values are between 1 standard deviation below and 1 standard deviation above the mean. This ends my video right here. And if you want to get to know how you can use this information to your advantage, watch the next video. Thank you.